I want to take a minute to look at derivatives and try and think about what they actually mean to us. So, we have looked at derivatives before. We have several different ways of writing them: y prime or f prime or dy dx. Those are all different ways of saying the exact same thing: the slope at a moment, the change, the rate of change. And so when we look at a function, sometimes it's written in terms of f of x, but it really means, hey, we have one value that is changing on top, and you could think of that as the dependent value. And on the bottom, how is the dependent value going to change as related to the independent value? Let's take a look at an example, like the example right up here on top. We're talking about a city's population, and I'm using this general notation here. Oh, it's just some function f of t. Well, f of t supposedly represents p, which is a population. So this whole function is related to a population. Do not for one moment think that this is going to be dy over dx. What we have here is some kind of change in population over a change in time. And to be more specific, we're looking at a change in people, thousands of people, over a change in years. So as we look at these problems, you have to be thinking, what does my function represent? When I see f prime, I want you to think about, hey, what is that the change of? The change of the independent and the change of the dependent, and where do they go and which one's on top and on bottom? Those are the units that you'll use. So I'm going to clear this up, and we're going to look at the problem that we have in front of us. In this problem, part A, if f is equal to 8, excuse me, if you have f of 8 equals 158, I'm so good at reading. What are the units of 8? Well, that's easy enough. When we're talking about 8, is that related to the time or the population? And as soon as you realize that, oh yeah, this function's f of t, we realize, oh, in part A, 8 is in years. And 158, what are those units? 158 thousands of people. So the units are thousands of people. Now, think about part B. What does that statement tell us? Well, once again, a very nice problem. What it means is, wait, it's not even 8 years. Technically, it's 8 years after 1980. We're measuring the time since 1980. So I think what this is telling us is, if it says t is 8, we're talking about the year 1988. And since the number represents the population, in 1988, there were 158,000 people in this town. So notice I'm just using the units a lot. I haven't even looked at derivatives yet, but I'm going to next. Because in part C here, now we're getting down to a derivative. F prime of 8 equals 2.5. What are the units of 8? Well, 8 still has not changed. 8 is still in years. But when we're looking at the derivative of f prime of t equals 2.5. That means, once again, we're looking at a derivative. We need a change in something, a change in population over a change in years. The units would be thousands of people over years. That's a horrible way to write it, but that's exactly what it is. Thousands of people over years. That's the units we're looking for the derivative. It's really important to read the problem and just figure out which units go with which. We'll do the last 3 parts in the next video.